In Lesson 9.5, we're going to continue looking at the format of linear equations and what they mean for our graphs. 9.4, we talked about direct variation equations. It was just y equals a number times x, nothing added or subtracted on. With that direct variation equation, this m, remember, was our constant of variation, or our constant rate of change. And since nothing was added on, our point went through the origin, because origin is 0, 0, so it's like adding 0. Today we're going to see what happens if we add something on. As long as we have this important part, a constant rate of change, remember, also called slope, as long as we have that multiplied with x, it is linear, just like direct variation equations are linear. But when we add something on, it moves it around the graph so that it is not at the origin anymore. So here, when I see y equals 3x, I know my slope, which means the same thing as constant rate of change. I know my slope is 3. However, since I want my y-intercept to be 4, and you should remember from lesson 9.2 that y-intercept means where it will cross the y-axis, that means I need to add 4 onto my equation. So instead of crossing at the 0, it goes up 4. So the point 1, 3 would be my point if I just had the constant rate of change as 3. However, since I'm adding 4, it'll actually be 1, 7. So when I tried to divide 7 divided by the 1, I would not get that constant rate of change of 3. That's why it's not direct variation. If my equation says y equals x minus 1, what is my slope, or what is my constant rate of change? Well, what's the coefficient of x? It's always look here next to the x. When it doesn't show, you should remember that is 1. What is my y-intercept? Be careful not to say 1, but it is negative 1 because the minus 1, just like in chapter 7 when we looped it. That means the line would go down a spot. Push pause on the video right now to try these two rows, see what you can fill in each of these marks, and then come back and check yourself. Since I wanted my slope to be negative 5, I knew my equation had to be y equals negative 5x. Since it says plus 2, I know my y-intercept will be 2. Slope, whatever is attached to the x, is 2/3. The y-intercept is 0. Ah, yeah, 0 means it crosses through the origin. If I look back over here, yes, that's right. It's just y equals mx with nothing added on, or you can imagine it with the plus 0 to help you remember that the y-intercept is 0. Remember to write y-intercepts, the x-coordinate is always 0, so this would be like the point 0, 4 on a graph. This would be like the point 0, negative 1, meaning if I substitute in 0 here, the value would be 4. If I substitute in 0 here, the y value would be negative 1. Also remember what slope means from lesson 3. A slope of 3 means it's an uphill, very steep line. A slope of 1 means it's still uphill, but it's a perfectly diagonal 45-degree angle line from the x-axis. A slope of negative 5, negative means it's downhill and it's very steep. 2/3 means it's uphill, but it's pretty shallow because it's a fraction. It's less than 1 whole. So remember how slope tells us about which direction the lines goes and how steep it is. Just like in lesson 9.2, before we made our table of ordered pairs to graph our linear relations, sometimes when we're looking for slope and y-intercept, we have to solve first to get y by itself. Whenever we're talking about slope-intercept form, you always need it to look like this. Y equals mx plus b. Y equals the slope times x plus the y-intercept. And that might help you to remember that. So here I do not have y by itself. I have it added on with a negative 4x. To get rid of negative 4x, I would need to make a 0 pair, so I put positive 4x on both sides. Negative 4x and positive 4x are 0. So on this left side of the equal sign, which remember you can think of as like your balancing stick, then I just have y, which is good, that's what I want. On the right, please be careful, do not say that that is 6x. This is not like terms, so we have to leave them separate. So it's like saying 2 plus 4x. If it tells you to do 2 plus 4x, I literally just write it. But since my slope-intercept form says to put the x first, I would write 4x plus 2. Commutative property says I can add in reverse, and that's fine. If you went straight from here down to that and you remembered to put the x first, that would be terrific. Then it says now state the slope and the y-intercept. Our slope is m, and that is a slope of 4, so it will be an uphill steep line. And our y-intercept is the b in the formula, and that is 2, which means when I plotted the point, I would plot 0, 2 on my graph. Okay, push pause and do the u-try. Get it into slope-intercept form, and then state what your slope and your y-intercept are. When you got it into slope-intercept form, it should say y equals 5x plus 10. So your slope is 5, and your y-intercept is 10. So what does this mean for us? How does this affect the graph? Well, let's see. Y equals negative 2/3 x plus 3. Our slope is negative 2/3, which means it will be a downhill, fairly shallow line, and our y-intercept will be 3. You know from lesson 9.3 that slope means rise over run from one point to the other point. Well, we have no points on here to count of a slope of negative 2/3. That's why when you make your graphs, you always graph the y-intercept first so that you have the point to base off of. So the y-intercept of 3 means 0, 3, because y-intercept means the x is 0. So I put my first point on the graph right there. A slope of negative 2/3 means from that slope I need to rise down 2, run positive 3, which means right 3, and put another point. My requirement for my class is your linear equations and your graph should always have 3 points on them. So you either need to do it again from here, down 2, right 3, or you could remember that maybe the 2 was positive and the 3 was negative. So you can go back to your y-intercept and say positive 2, then negative 3, left 3. Just be careful not to make the 2 and the 3 negative, because negative over negative would make positive, which we don't want. So I have 4 points here. As long as you have 3, you would get full credit. Use a ruler or your ID card or something nice and straight. I cannot get a straight line on my computer, but I'll try my best. Connect the points. Ooh, not a good start for a straight line. Sorry, I'm really bad at that when I don't have an actual paper that I'm writing on. And put arrows at the ends. Please do not just play dot to dot and stop at the points. Go so that your line goes as much across the coordinate plane as you can, and the arrows show that they go on forever. If I had a nice straight line, which unfortunately I do not, then every point that landed on this line, you would know that that makes this equation true. So here, like the point 1, comma, looks like it's a little bit above the 2, and since I'm dealing with thirds, probably 2 1/3. Let's see if that's right. Negative 2/3 times 1 is negative 2/3 plus 3, yes, 2 1/3. So the point 1, 2 1/3 makes the equation true because it lands on the line. The point 0, 1 does not land on the line, so it would not make the equation true. Right now, flip your paper over and do this u-try at the top. My hint to get you started is before you try to make your graph, tell me what is the slope and what is the y-intercept. And you can think of your y-intercept as a number and as a coordinate of 0, whatever that number was. Remember to start at your y-intercept, then use your slope to move to make the graph. So push pause. Once you're all done, come back and check yourself. The slope was negative 1 because their coefficient wasn't showing. Because I need a rise and a run, anytime I have an integer slope, I can picture it over 1. So negative 1 over 1. My y-intercept, I hope you did not say 2. I hope you saw minus 2, so you knew it was negative 2, which means my line was moved down 2 places from the origin. So I started at that point, and then my rise was negative 1, my run was positive 1. My rise was negative 1, which means down 1. My run was positive 1, which meant right 1. Or you can go in reverse. Up and left, positive over negative, still makes the slope of negative 1. If you did not get that correct, please push, pause, erase, and fix that based on this information that I just explained. Once you are ready to go, we will work in reverse. The graph will be made for us, and we'll try to write our own equation. Again, these points are the important parts. M stands for slope. So the slope I can count like in lesson 3, I can count the rise over the run. So from one point to the other, I see that I'd have to rise 2 and run 1, 2, 3, 4, 5, 6. I would rise 2 and run 6, which actually simplifies down to 1/3. If that is correct, then if I rise and run 1 and 3, I should land on the line. So let's see how I do. Rise 1, run 3. There it is, point on the line. Perfect. Another way you can find the slope if you can't count or if the points are too far apart, you can use that formula we learned in lesson 9.3. Remember where you take the second y-coordinate and subtract the first, and then the second x-coordinate and subtract the first. So the second y-coordinate was a 5. If I subtract the first y-coordinate, which was a 3, then I would get 2 for my numerator. Denominator, the second x-coordinate is a 6. The first x-coordinate was a 0. 6 minus 0 is 6. And there's the 2 6, which would simplify to 1/3. And remember, it doesn't matter which point you use as your first and second point, as long as you stay consistent. My y-intercept, I look on the y-axis. I see the line crosses 3 spaces above the origin. So my y-intercept is a positive 3. So my equation is y equals 1/3 x plus 3. It's always y equals your slope number times x plus the y-intercept number. Okay, let's see if that makes sense to you. Push pause, do the U-try, and then come back and check yourself. If I do my count, I went down 4 spaces and then right 2 to get to the next point. So negative 4 over 2 would simplify to negative 2 over 1 when I'm counting a rise and a run. But when I write my equation, I write it in simplest form as just a negative 2. My y-intercept, I count above the origin. The line crosses 4 spaces above the origin. There wasn't an exact point there, but I could put it there because the line touches. So my y-intercept is 4. So when I put them together, my slope, or my equation, is y equals negative 2x plus 4. This was a positive slope, so the line went uphill. This was negative, the line goes downhill. Always check that that makes sense. This is a small slope, so it's a very shallow line, meaning something that would be reasonable to bicycle or rollerblade up. This is a very steep line because the absolute value of the slope is more than 1, so that would be trickier to work on. Like your bike would be rolling really fast if you went down there. It'd be hard to control it. To wrap up this lesson, let's do a summary by summarizing the key steps. Push pause and see if you can connect the steps in order, and then come back and check. Step 1, before you begin anything, you have to know what your slope and your y-intercept are. Once you know those two numbers, the y-intercept is the one you start with, so step 2 was D. From that point, then you can find your other points. Technically, you only need 2 points to connect. That would make a straight line. But in my class, the requirement is you have to have 3 points, so I added and the third point. And then please don't stop once you have your points. You need to connect them to show that there would be other coordinates that make the equation true as well. And so here, I cross this out to say 3. Make sure also to add arrows on your line. As I said in the summary about connecting the lines so it shows that more than one set of coordinates can make the equation true, I realized you may not know what I'm talking about. So I'm going to end this video by showing you with these equations that we wrote for these graphs. This says if my y always equals 1/3 times my x-coordinate plus 3. So for this point right here, I would say the y-coordinate is 5 equals 1/3 times the x-coordinate plus 3. Well, 1/3 of 6 is 2, and when I add 3, yes, I get 5. Remember when I counted my slope of up 1 over 3, I added another point right here where the line was? Well, that is the point of 3, 4. So if I put my y-coordinate in, and then 1/3 of the x-coordinate plus 3, well, 1/3 of 3 is 1, and when I add 3, yes, I get 4. Any point on this line, even if it's not neat integers, it would make the equation true. Any point not on the line would not make it true. One more to show you. Here my y-coordinate is negative 2 equals negative 2 times the x-coordinate, it says, which is 3, and then plus 4. Negative 2 equals negative 6 plus 4. Yes, that does equal negative 2. That's a true statement. So you can always make sure your equations are correct by finding points on the line, substituting them into your equations, and make sure they are true.